So this is Mastering Physics, Chapter 14, number 51. And the problem is this. In the figure, we have a 1 kilogram mass riding on top of a 5 kilogram mass, and it's oscillating on a frictionless surface. The spring constant is 50 newtons per meter. The coefficient of static friction between the two blocks is 0.5. What's the maximum oscillation amplitude for which the upper block does not slip? So you'll see I've already made some notations on my diagram. I've circled what I'm going to call the system with a dotted circle. So M1 is going to be our system. That's the upper block. I'll label the lower block, M2, and we'll do a force diagram. I have the normal force in the positive y direction. I have the weight in the negative y direction. They're equal and opposite. And I have the friction in the positive x direction. So I am making an assumption here. This moment that I have taken a snapshot of the system, I'm assuming that the system is accelerating to the right. So there is currently a net force to the right on the system. Now what is that net force? Well, in the x direction, the net force comes from friction. So let's write that down. So the net force in the x direction comes from friction. So the maximum possible static friction is the coefficient of static friction times the normal force. But according to our force diagram, the normal force is just the weight, M1 times G. Now, in general, remember, Newton's second law says the net force is equal to mass times acceleration, because we're using the maximum possible force, because we want to know the maximum amplitude. We're also going to include the maximum acceleration. So now if I focus on this last piece here, divide both sides by M1, I get that the maximum acceleration is equal to the coefficient of friction times G. But I know the coefficient of friction is 0.5, and I know G, 9.8 meters per second squared. So the maximum possible acceleration provided by friction in this system is 4.9 meters per second squared. So the blocks will move together if the acceleration is less than 4.9 meters per second squared. If it's more, there's not enough friction available to cause that acceleration of the first block. In other words, the first block will slide off the second block. So now, what do we know about simple harmonic motion? So what's the condition that relates maximum acceleration in simple harmonic motion to the amplitude? Remember, we talked about this in class. The maximum acceleration is omega squared times the amplitude, and in this case, the maximum amplitude if we're considering the maximum acceleration. So now, let's solve for what we're looking for. The maximum amplitude is equal to the maximum acceleration divided by omega squared. Also, we know that for a mass spring system, in general, omega squared is going to be given by k over m. And for this system, we have two masses moving together. So we've got to include both of those masses. So now if we go back and plug in the maximum acceleration divided by this expression, the maximum amplitude will be given by m1 plus m2 divided by k, because remember we're dividing by omega squared. So if we divide by omega squared, we end up with the m1 plus m2 in the numerator and k in the denominator times the maximum acceleration. And we know all of those things. So if we plug in, the total mass is 6 kilograms, divided by the spring constant, which is 50 newtons per meter, times the maximum acceleration, which we solved for, 4.9 meters per second squared, and we get 0.59 meters, or if you like, approximately 60 centimeters. So, that is the maximum possible oscillation amplitude for the upper block. If you were to stretch the system, so what sets the amplitude for the system? Well, the source. You do. So if you stretch this system beyond 60 centimeters, the upper block, will slide off.